When studying algebraic expressions, I find it helpful to start with a graph. Remember that the slope of this graph gives us the velocity, and since slope is rise over run, we end up with change in position over change in time. So I like to start here. Before we see any problems though, let's take a quick look at the units. Okay, so units for velocity are meters per second, and units for displacement are meters, and units for time interval are seconds. So everything matches up there. So in this first problem, they're asking us to find average speed. So it looks like we're already set up with our velocity equals displacement over time formula. I leave it to you to plug in the numbers and find the answer. In this next problem, they're asking us to find how far does the fire truck travel in 20 seconds. So what we're looking to do is isolate this displacement in our formula. Okay, we can do that by multiplying both sides of the equation by the time interval. What that does is move this over here. There we are. And since we already knew the velocity and the time interval, I leave it to you to plug in those numbers and find the answer. But since we did some rearranging, let's double check our units and make sure everything still works out. Okay, our units for velocity are meters per second. Our units for time are seconds. And our units for displacement are meters. Okay, now if we multiply meters per second times seconds, we should get them to cancel. So we end up with meters on both sides. Everything checks out. In this problem, we're trying to figure out how long it would take to travel a certain distance. So what we need to do now is isolate the time interval. Okay, there's a two-step process for doing this one. We're going to multiply both sides of the equation by the time interval, moving this over here. Okay, but remember what we wanted was the time interval by itself. So now we're going to divide both sides of the equation by the velocity. And what that does is moves the velocity back over here. And there we are. Analyzing the units on this one can get a little tricky, but stay with me here. Time interval is in seconds, and displacement is in meters. Now the velocity is in meters per second. But now see, we have a fraction within a fraction. But if you recall, dividing by a fraction is like multiplying the reciprocal. So what we really have up here is meters times seconds over meters. I'm multiplying the reciprocal of the units. See that? And now my meters cancel and I end up with seconds and seconds. Everything matches up. Okay, in this problem, they're not asking us for a change in position, they're asking us for a final position. So we want to know after 3.6 seconds, where are you going to be? So we need to look at this formula. It looks fancy, but here's all it means. Where you're going to end up is where you started plus however much your position changed, your change in position. So if we can figure out that change in position, we should be able to just add it straight to that 59 up there. Okay, so here we go. Let's rearrange this guy down here to get displacement by itself. We've done this one time before. Multiply the time interval on both sides, and there it is. So now all we have to do is replace displacement with our new expression for displacement, velocity times time. Let's do that. And there you have it. So all we have to do now is plug in where we started, how fast we were going, and how long it took. One last time, let's make sure the units match up. So for a position, we'll have meters. For a velocity, we'll have meters per second. And for a time interval, we'll have seconds. Since we're multiplying these two together, the seconds will cancel. So we end up with meters plus meters, which is going to be equal to another position, which is meters. Everything adds up.